Hello, good day viewers. You are welcome to my channel. This is Chemistry Hangout. Today we are going to be comprehensively looking at the Neco 2021 Chemistry Practical, the volumetric analysis. Of course, I know a whole lot of students might be panicking now because sometimes this chemistry gives them tough time. But we are here on this channel today to actually comprehensively look at the procedures, step-by-step guide to getting A in the Neco 2021 Chemistry Practical. So, welcome to my channel once again. Take a seat and chill. You're going to have a wonderful time today. Now, the Neco 2021 Chemistry Practical for the volumetric analysis, of course, we'll be giving solution A. If you look at this labeled solution A, we'll be giving solution B, labeled solution B. And here in front of me, I have my burette already with my clamp. Okay, I've clamped my burette to the burette stand or my retort stand. I have my conical flask here. Okay, I have my wash bottle that contains water, and I have my indicator, which is melty orange. Okay. Now, you don't need to stress yourself because this practical we actually want to carry out. There are procedures for it, and you'll be given the procedures in the exam. Okay. Now, let's take a look at this. Take a look at this. Let's take a look at this. If you look at this now, you said A is a solution containing sodium hydrogen tetraoxosulfate 6, which means this now, your A, solution labeled A is this, okay? And we have B is a solution containing 3.75 grams of sodium hydroxide. So which means this solution, the sodium hydroxide as instructed in the question, okay? You now said, put A into the burette. Can you see? That's an instruction now. Put A into the burette and titrate against 20.0 centimeter cube or 25.0 centimeter cube portion of B using melty orange as indicator. Now let's take it step by step. Put A into the burette. So we want to put A into the burette now. This is A. Of course, I want to believe we should actually know the precautions for our titration. If you don't know it, before you start titrating, you have to wash all this your glassware, this apparatus with water. Then after washing with water, you wash with the solution they are supposed to hold. Okay. Now I've washed this with water already, and I've washed my burette. My burette is to hold the solution A, which is the acid. I've washed it with my acid because I'm going to put my acid in the burette. And for my conical flask, I'm going to pipette 20 or 25 centimeter cube of B in my conical flask. I've also washed my conical flask with solution B, which is the solution it's going to hold. We are doing all this because when you wash your glassware, your apparatus with water, you still have some droplet of water in those apparatus. So, and it will affect our readings. And thereby, it might actually make our average titer to be wrong. So we wash with the solution that will hold to ensure that we have an accurate result. So I've done that already. Please don't forget to do that. I've done that already. Now the question now is they said we should put A into the burette. So where is solution A? If you look at this, this is solution A. Now I'm putting solution A in the burette. Don't forget, I have clipped my burette already, so that when I put the solution A, it will not be running down through just my burette. So this is solution A in the burette. Very, very important. This solution A in the burette. Solution A in the burette. Carefully. Okay, to the 0.00 mark. Look at that. Very important, to the 0.00 mark. Okay, before I do that, of course, I'll prepare my table now because I want to begin the practical. So I want to prepare my table because we are going to be instructed that repeat the titration to obtain consistent titers, tabulate your readings. So I want to have a table so that when I get any value on my burette, I can actually record in my table. So I will have my burette readings. Please pay attention to this table, very, very important. My burette readings, the units, that's in centimeter, cube. Okay, my final readings. This will be my final readings. I will have my initial readings. Please use your ruler, the very straight table. Please don't be in haste. This is an exam. I want to actually minimize errors or mistakes. So we have burette readings. I can have my rough, okay, in centimeter cube. Very important. I will have my first titer, okay, in centimeter cube. I hope you are following. And I will have my second titer in centimeter cube. Now, very, very important. I can have a minimum of 3, which will be rough the first one, first and second. I can actually have 4. Yes, I can have 4 too, which means I will have rough, I will have first, I will have second, and I will have third. But for this, we'll be performing 3. So 1 for rough, the first and the second. That's okay. You will not be penalized. You will not be penalized in the exam. So you can have 4 titrations, which means 1 for rough, first, second, third, or you have a minimum of 3, which means rough, first, and second. So for my practical, I'm taking 3. Okay, very, very important. Now, please, they say it's a table, so endeavor to tabulate your readings. Very, very important. Our initial. Okay, then here we have volume of acid used. Okay, so we have volume of acid used here. This, I hope you are paying attention. So we have our rough, we have first, we have second, we have final readings, we have initial, then we have volume of acid used. Okay, now if you look at this, please pay attention now. Before I start titrating, I need to remove the funnel. Very, very important. I need to remove the funnel. Why am I removing the funnel? Because if you start titrating, there is no way you will have droplets of the acid in the funnel. So when you start titrating, the drops in that very particular funnel will still be dropping in the burette. Thereby, it will be increasing the volume of the acid you have there, even if you are titrating it, and it will make our readings to be accurate. So we remove our funnel, and if you check here now, if you check my readings, that's my readings, the readings of the burette before I start titrating at all. So if you look at the readings here, which is my initial readings, is what? Is 0.00. Please, for accuracy's sake, the values in our table must be to 2 decimal places. Very, very important. 2 decimal places. So my initial, before I started titrating, is 0.00. So the acid is on the 0.00 mark, is on the 0 mark, but that's why I have 0.00. Okay, that's the first instruction. Then I said, repeat the titration. Okay, is I put A into the burette, you have done that, and titrate against 20 or 25 centimeter cube of what? Portion of B, using mercury as indicator. So this is my pipette. Please, you need to check the pipette you are using in your various schools. You have 20 centimeter cube pipette, you have 25 centimeter cube pipette, and that's the reason why they instructed you that it might be 20, it might be 25. But for the sake of this practical, we are using 25. So this 25 centimeter cube pipette, okay? This 25 centimeter cube. And this is the solution B. So I'm pipetting 25 centimeter cube of solution B in this my conical flask. So we are doing that now. Please, gently when you are pipetting, I know students are always afraid of this, but it's very simple. Okay, just pay attention. Don't forget, this is the 25 centimeter mark. So pay very much attention to it so that you don't suck little of the base. Okay, so you are pipetting 25 centimeter cube. Okay, look at that. It's more than the 25 centimeter cube. So I'll just be releasing my hand a bit so that, you know, it goes to that very particular mark. That very particular mark. Okay, so perfect. So I have 25 centimeter cube. Okay, transferring it. Get that now. Transferring it into my conical flat. Very important to bring it closer, transferring it into my conical flask. So after that, then I'll put my indicator. You'll be giving that either methyl orange. If you are giving methyl orange or phenolphthalein, you can use methyl orange, you can use phenolphthalein. So any indicator provided for you in your various schools, it's okay, that methyl orange or phenolphthalein. But here I'm using methyl orange. Sometimes in the exam, they might ask you to use phenolphthalein. There is no cause for that. You are still going to get an accurate result. Okay. So, but for the sake of this, I'm using my methyl orange. So I'm just using 2 drops of my methyl orange in my conical flask, 2 drops. First drop, okay. Then I have the second drop. So these 2 drops of methyl orange, just 2 drops. Then I said what? Portion I'll be using methyl orange as an indicator. So I begin to open my clip gently so that the base, okay, look at the color before I start titrating. Look at this color, this around yellow, okay, this yellow. Now immediately I start running this very particular acid in the conical flask, and I notice any color change, meaning neutralization has taken place. I need to stop and take the readings from my the record in the table. So we have this gently begin to run it into my conical flask. Okay. Okay. Gently. Can you see that? You can see the color is about to change. So you put in drop. Very, very important. In drop now. In drop to get an accurate titer. In drop now, you can see that in drop now. You can see in drop. Okay. In drop. Okay. In drop. You can see in drop. Very, very important. If you look at the color now, it's not yellow again, it has changed, meaning neutralization has taken place. Then I'll take my readings. Okay, from my burette now, I have my readings to be 22.60. From my burette now, I have 22.60. That's my rough. That's my first titer. Okay, that's my first titration. That's my first titration now. Very, very important. That's my first titration. Now, that's my rough now. For my first now, I can decide to refill my burette so that my initial again becomes 0.00. I hope you are following. My initial can be 0.00, meaning I'm refilling my burette. But because I'm working with time, very, very important. Because I'm working with time, I might decide not to refill because of time. I still have other questions to attend to. So I can take my initial again from this very particular burette readings, which is my initial here will be what? 22 now, 0.60. I hope you are following. So my initial now will be 22.60, which means I did not refill. I started another titration from this very particular readings. But if you are not comfortable with this, you can decide to refill again. Okay? If you are not comfortable with this, you can refill again to the 0.00 mark so that your initial again becomes 0.00. Are we together? Okay? Come, let me get this, pour this. Okay? So that I will have this. Let me just pour it here. I'm done with this already. Okay, I'm done with this already. This is water. Let me wash. Because I'm doing the second one immediately. Okay, let me wash. Wash it. And open this. So that I wash this very particular one. Okay, so wash this with water already. Don't forget the rule. Immediately after washing with water, I need to wash with the solution is 2O. Now the solution, this is 2O, the conical flask is the solution B. So I have to wash with solution B for accurate result. So I hope you are following. Okay. Now the same thing. I have to do the same thing again. I have to do the same thing. which is pipette 25 centimeter cube of this, put in this, then I titrate again. So I have this. You can see it's not up to. Okay, so I will release my hand gently. Okay, gently, 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 until that very particular mark. Okay, perfect. So I run into my conical flags. Okay, very simple, practical. Just pay attention to it and you're fine. Okay, so from there, don't forget 2 drops of our indicator. 2 drops of our indicator. That's 1 and 2. Okay, that's 2 drops of our indicator. Gives us the yellow color. Is that okay? Then we start titrating again. Start titrating. You can see. So since we did not refill, you know, it will be faster because we are working with time. Begin to run into. Let's see that now. Okay. Can you see that now? You see? Can you see now? Color change from the yellow now. Can we see that? There's a color change already. So I'll take my readings for my bread. That's 49. No, that's 40. Okay, that's. So this is 44.90. That's 44.90 already. So very, very important. I can now refill my burette now because you know the acid here now will not be enough to actually cater for the last titration. So I have to refill my burette. Don't forget you are working with time. Don't forget your solution A is going to be in the burette very, very fast. So I can add this now. Refill to 00 mark so that, and I can sign up to refill to 00 mark. It depends, but you can just refill so that you don't stress yourself. You can refill to 00 mark, to the 0 mark, okay? So don't forget, I told you before titrating, you have to remove this more than the 0. So I have to run little of it in this place. Fine. So that is that. So we are done with this already. So I'll just put it here so that I can dispose that later. I wash with water, okay? I wash with water. After washing with water, don't forget, you are still going to wash with the solution. It is too old for accuracy, okay? So I wash with water already. Don't forget, solution B is to be here. So I will wash with solution B, little portion of solution B. Very, very important, you know, in this place already. Okay, now the same thing again I'm doing for this. Titrate this, okay? I'm pipetting B again into this very particular conical flag. So I pipette, using my pipette now. Okay, gently, 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 gently. Perfect. So, okay, run into my conical flag, which will be my last titration from now. Very, very. Okay, so I hope we are following. I hope you are following. Okay, so my 2 drops of melty orange, very important. 2 drops of melty orange. That's 1. That's 2. Okay. So gives us that yellow color. Obviously that gives us that yellow color. So I'm titrating now. So which is the last one. Don't forget, just gently. Okay, please pay attention to this. Gently now, gently, gently. Gently, beats. Okay. We're changing from the yellow color. Can you see that now? Changing from the yellow color. I take my readings again. That's still, oh, perfect. That's still 22. Okay, 0.30. Don't forget, our initial now will be what? 0.00. So that will be 0.00. That's fine. We are done with this now. So you can just, you can just put it aside now. We are done with this. It said repeat the titration to obtain consistent titers. Very important now. Can you see consistent titer? So we subtract to get the volume of acid used. This will be 22.60. This is 22.30. Perfect. This is 22.30. Please pay attention to that. Very, very important. It said repeat the titration to obtain a consistent titer. Meaning, if I'm using 3. If I'm titrating for 4, which is around first, second, and third, 2 out of that must be the same, consistent titers. Okay, so tabulate your readings and calculate the average volume of acid used. I've tabulated my readings. Don't forget, you are going to indicate the volume of the pipette used. The volume of the pipette used, okay, must be indicated because we have 20, we have 25. That would be 25 centimeter cube. And you must tell us the indicator used because it's possible for us to use phenolphthalein or melty orange. Anyone you are using, no problem. You are fine with that. As instructed, just follow the instruction in the question. So we are using our melty orange. Please don't forget this. Very, very important. It has to be indicated. Now, tabulate your readings and calculate the average volume of acid used. We have tabulated our readings now. Okay, you want to know the average volume of acid used now. You know the volume of acid used to the 22.60, 22.30, 22.30. I hope you are following. So, but if you look at the rough, it's a bit far from the first and second. So I'm not using the rough. I use this 2. Then I divide by what? 2. Okay, so I want to calculate the average volume of acid used now. So average volume of acid used is equal to the 22.30 plus 22.30 divided by what? By 2. Okay, so from there, calculator, okay, the average volume of acid used, average volume of acid used is going to be what? So 22.30 plus, let me have that calculator. Let me have the calculator there. So I will have 22.230 plus 22.30 divided by 2. Definitely, it's going to give us 22.30 centimeter cube. I hope you are following. I hope you are following. Average volume of acid used, that's 22.30 centimeter cube. Okay, from there now, after you have gotten the average volume of acid used, very important, you now said the equation of reaction they have given us. So from your results, these are our results, and the information provided above, that's the information they gave us. They said we should calculate the 1 concentration of B in mole per dmK. What is the B they gave us containing this? This is in gram, okay? You now want us to get it in mole per dmK. So question 1 now. Concentration of B in mole per dmK. So from here now, we know this formula already. You know this formula already, which is mole is equal to mass over molar mass. We know this already, okay? If you don't know that now, please take note of this. Very, very important information. Mole is equal to mass over molar mass. Now we are getting concentration of B in mole per dmK. Mass, they have given us the mass in the question. The molar mass, we can calculate it. So we can say now, just modify this very particular formula. I can say concentration in mole per dmK is equal to concentration. Let me write it in full. Very important. This is an exam. Concentration in mole per dm cube is equal to concentration in gram per dm cube over concentration in gram per mole. I hope you are following. So, very, very important. I want to get concentration in mole per dm cube. What is my concentration in gram per dm cube? You don't just lift values. You need to tell us where you got the value from in gram per dm cube. It's given in the question already. That's 3.75 gram per dm cube. Okay? Now, our concentration in gram per mole of B, which is sodium hydroxide. So, our sodium hydroxide would have given us the atomic masses in the question. So, we have 23 plus 16 plus 1. So, that will give us, this 39 plus 1, that's 40 gram per mole. I hope you are following. Please, very, very important. Those units are very, very important. So, from here now, what do? We can say concentration in mole per dm cube is equal to 3.75 gram per dm cube over 40 gram per mole. Can we see? That's why those units are important. Gram, we cancel gram. Then our concentration now, our concentration in mole per dm cube is equal to, so 3.75 divide 40. So I'm adding 0. Please, to 3 significant figure, very, very important. 0, 9, 3, 3.75. That's what I have here. So I'll say 3.8 mole per dm. That's sorted. That's question 1. Concentration of B in mole per dm cube is 0.0938 mole per dm cube. Okay, we move to the second one. Concentration of A in mole per dm cube. Look at A. It's a solution containing this. They didn't even give us either the mass or the mole. Okay, which means here now B is standardized already because they gave us the value. So we want to use the standardized NaOH to get the NaHSO4 now. Can you see that now? So concentration of A in mole per dm cube. Don't forget our normal formula. Mole is equal to mass over molar mass. But it cannot solve this because they did not give us the mass, they did not give us the mole. And we cannot be looking for two unknown at the same time. So we use our titration formula. So we say using CAVA over CBVB equals NA over NB. I hope you are following. Okay. And what is our Ca? Our Ca is the concentration of acid. You might not decide to actually write. You can just tell us our Ca, the value for times saved. For times saved, you can just say, okay, our Ca, very, very important. Any value you want to bring in, you must tell us where you got it from. So that's concentration of A, which is the acid now, which we have gotten here, okay? But here, they say concentration of A in mole per dm cube. So we are looking for our Ca now, so we don't know this. So our Va, volume of acid, that's the average volume of acid used, which we commonly call titer value. So this is 22.30 centimeter cube. Please, you have to pay attention to this. Irrespective of the titer value, it's possible for the titer value in your own school to actually change a bit, but the procedures, the formulas remain the same. Okay, this is my own titer value when I carried out the titration. Yours might be different, okay? The one for your school might be different, but the procedure, the calculations are the same. Okay, so that's our VA, that's my own volume of acid. So my concentration of base, that's what we have gotten. Concentration of B, that's concentration of B. So we have gotten that that's 0.0938 mole per dm cube. I hope you are following now. Okay, our VB, that's the volume of base, and the volume of base is the volume of pipette. That's why it has to be recorded, which is what? 25 centimeter cube. Are we together? Now, our number of moles of acid, we have to go back to the equation of reaction. Okay, we have to go to the equation of reaction, balance this balanced already because they gave us this in the question. Definitely is supposed to be balanced. Okay, if you look at it, it's balanced now. So this is the acidic, because it's an acidic salt, that's the base. The acidic salt is acting as an acid now here. So the number of moles of acid here, you have 1 mole of this. So number of moles of acid, that's Na is 1. Okay, number of moles of base, if you look at this, you have 1 mole of sodium hydroxide 2. So you have Nb2 to be 1. I hope you are following. So from there, we can look for our Ca. Very, very simple. So from here, Ca, you don't know, times Va, 22.30 over Cb, 0.0938, okay, times Vb, 25, is equal to number of moles of acid 1 over 1. Very simple. So we make Ca the subject of formula here now. So we have Ca to be equal to 0. When you cross multiply, for sake of people that don't understand this, let's cross multiply now. So we have Ca times 22.30 times 1, can you see that? Equals 0.0938 times 25 times 1. I hope you are following. So we are looking for Ca, so we divide both sides by 22.30. So we have Ca to be equal to 0.0938 times 25 times 1 over 22.30. So our Ca becomes, use your calculator, please, very, very careful. You have to be very careful. 0.938 times 25, okay, times 1, as equal to then divide by 22.30. So I have 0.1051, but 3 decimal place. Please don't forget 105, approximately to 3 decimal place, mole per d. Perfect. Okay, as perfect, we're almost done. Then we have concentration of A in gram per dm cube. So we have gotten it in mole per dm cube. They want us to convert it back to mass. Very, very important. That's why I said, please pay attention to this formula. Very, very important. So we have gotten the mole for Ca now. They want us to get the mass. Can you see that? They want us to get the mass. We have the mole and can calculate the molar mass because the molecular formula is given here. So perfect. So we are coming back to say concentration in mole per dm cube is equal to concentration in gram per dm cube over concentration in gram per mole. Can we see that now? So we have concentration in mole per dm cube, which is this that we have gotten. So here our concentration in mole per dm cube is what? Is 0.105 mole per dm cube. I hope we are following. Then our concentration in gram per dm cube, concentration in gram per dm cube is what? Is what we are looking for according to the question. Now our concentration in gram per mole, now we can calculate that in gram per mole of sodium hydroxide. Can we see they have given us Na to be 23 plus oxygen to be 16 plus 1. So we are going to have 40 gram per mole. Perfect. Please take note of the unit. Very, very important. So from there, our concentration in gram per dm cube will be equal to what? Will be equal to concentration in mole per dm cube times concentration in gram per mole. Perfect. So we have concentration now in gram per dm cube will be equal to, what's our concentration in mole per dm cube? That's 0.105 times, what is our concentration in gram per dm cube? That's 40. So our concentration in gram per dm cube is equal to, so we have 0.0105 times 40. Then we have 0.105 times 40. Then we have 4.2. So we got 4.20 or 4.20 gram per DMK. I hope you are following. 4.20 gram per DMQ. So we have 0.105, okay, 40, then we have 4.20 gram per DMK. Now, from here, which is our A now, please don't forget, which is our A now, okay? So, we now have concentration of A in gram per DMK, which we have sorted for now. Mass of Na2SO4 formed during the titration. Because immediately I titrated, this is the product, okay? This is the product now. This is the product, sodium sulfate and water. That's the product. So what will be the mass of this that will be formed? If I actually, because this is a way of actually producing salt in the laboratory. So what will be the mass of this? Very, very important. How do I get the mass of this? If you look at this, they did not give us any information about it. But I can calculate the amount in moles of this, then to get this. So I can say amount in moles of sodium hydroxide. I can calculate that. So amount in moles of sodium hydroxide, that's concentration times volume over 1000. Okay? So the amount in moles now, amount in moles will be equal to, what is the concentration of sodium hydroxide? That's the concentration of sodium hydroxide, which is what? Which is the B. That's CB. So this is it. That's 0.0938 times, what is the volume of sodium hydroxide pipetted? That's the base, don't forget. So that's 25 over what? 1000. Okay, so my amount in moles equals 0.0935. I'll be 0.0938 times 25 Sorry, I'm seeing a mistake. Concentration of A in gram per dm cube. Sorry, we have this concentration of in gram. That's A. This A. So we went to calculate for sodium hydroxide. So it should be for this, please. NaHSO4, please. Because we are calculating concentration of A in gram. This is A. So that would be, it should be 23 plus 1 plus 32 plus 16 times 4, please. We are calculating A, not B. So we have 23 plus 1 plus 32 plus 64. That's giving us 23 plus 1 plus 32 plus 64. That's giving us 120. So this is 120 gram per mole, please. 120 gram per mole. So definitely this is times 120. Sorry, 120. So that will be times 0.105. So that's giving us 12.6 gram per DMK. 12.6 gram per DMK. 12.6 gram per DMK. So from there now, our amount in moles now. So please pay attention. We are calculating for A, not B. Concentration of A in gram per DMK. So it's 120, not 40. As used. That's the mistake. So from here now, our amount in moles become 0.0938 times 25, okay, divide 1000. That's giving us 0.00235, approximately 235 moles of sodium hydroxide. I hope you are following. Of sodium hydroxide. Now from the equation of reaction, if you look at the equation of reaction, 1 mole of sodium hydroxide gives 1 mole of sodium sulfate. 1 mole of sodium hydroxide is equal to 1 mole of sodium sulfate. Okay, so definitely 0.00235 moles of sodium hydroxide will be equal to 0.00235 moles of sodium sulfate. I hope you are paying attention, because they didn't give us any information about sodium sulfate, so they're trying to use stoichiometry now to get that. Very, very important. No, so if this equals this, they are not saying we should get it mass. Don't forget now. They are asked to calculate the mass now. So the mass of this, because we are getting the mole now. So you know that our mole is mass over molar mass. Okay? So the molar mass of this now, that's Na2SO4. That will be 23 times 2 plus 32 plus 16 times 4. So we can calculate that. 16 times 4 equals, so we can have 46 plus 32 plus 6 of 4. That will give us Na2SO4. That's the molar mass now. It will be 142 grams per mole. So what to get the mass now? So the mass becomes mole times molar mass. So we have mass to be equal to, what is the mole? We have gotten that 0.00235 times, what is the molar mass now? We have gotten that 142. So the mass becomes 142 times 0.00235. So the mass form will be 0.334 grams. That's the question. So if we look at that, very, very important. If we look at that, you have gotten the what? The concentration of B in mole per dm cube. Concentration of A, this is the concentration of A in mole per dm cube. You have gotten that, which is this. So concentration of A in gram, because this is A now. So calculating the molar mass, you have 120. Then we cross multiply. We are having 12.6 grams of what? Of A. Now our amount in moles, we have done that. So the amount, the mass of Na2SO4 that will be formed during the titration is 0.334 grams of sodium sulfate. Now, so you have to pay attention. If you look at the one we used as our practice question, B is the solution containing this, okay? Then they ask us to get B in mole per dm cube, and they ask us to get A in mole per dm cube and in gram per dm cube. It's possible for this B to be in mole instead of gram. Very, very important. So which means if they give you in mole, they give you B in mole, they will ask you to get B in gram, then get A in mole and in gram. And it's possible for them to give you the value for A, which means A is the standardized, is standardized already. Maybe A is the solution containing 12 point this. So they will not give you for B. So you get either in mole here, then you get this one too in mole or in gram. So anyone that they have given you, the calculations remain the same. If they gave you B, that means you calculate for A. If they gave you A, that means you are going to calculate for B. So with this now, with this very particular practice question, I hope we just go over it again and again so that you'll be able to get that. So thank you very much. Please, if you have not subscribed to this channel, I will urge you to actually do that. You can leave your comments, you can share with your friends, share with co-students like you, and I'm sure that it's going to help you. Thank you.